Good morning, students. Can you able to see the PPT screen?
Yes, ma'am.
Yeah. So in the previous class, we were discussing about basis path testing and path testing. So we already discussed testing life cycle, roles and activities of test manager, test planning, forming a test team, and the role and responsibilities of testing team, developing test plan reviews, test case design strategies also already discussed. Then we started with black box testing approach. In that black box testing approach, we discussed random testing. Then we discussed equivalence class testing. Then boundary value analysis also discussed. In the previous class, we started with white box testing approach. In white box testing approach, we discussed test adequacy criteria, coverage and control, flow graphs, paths, loop testing, and I think up to paths and loop testing we discussed. We need to discuss mutation testing. Have you gone through the PPTs? I already uploaded the PPTs in the Google Classroom.
Yes, ma'am.
What happened to Gohi? He's joining. He attended the previous class, 10 to 11 class.
Rahul joined, ma'am.
Yeah, Rahul.
Yeah.
He's joining.
Yes, ma'am, he's joining.
Can you inform him?
Yes, ma'am.
So any doubt in the previous class portions? For your understanding purpose, I added more slides. So the thing is, you need to understand what are the steps followed in each method, and an example code. You take an example code, how the example code can be tested using the particular method. So more slides I added for your understanding and easy readable form. So any doubt in random testing?
No.
In white box testing only we have random testing, equivalence class and mode analysis. The screen is visible to you all.
Yes, ma'am, it is visible.
All of you using a mobile phone or a laptop?
Laptop.
Okay, it's coming in full screen mode. So in the previous class, we discussed boundary value analysis. Boundary value analysis totally focuses on checking the errors and bugs in the boundary conditions, that is minimum range and the maximum range. While performing the boundary value analysis, what we will do, we will take the minimum constraint and we will give the minimum value. Say if the for loop starts from for I equal to 0, I less than 10, I plus plus. So the minimum value is 1, maximum value is 10. So in boundary value analysis, what we will do, we will give the minimum value 1 value above minimum value, that is 2, and 1 value less than minimum value. One value less than the minimum value, that is 0. So we'll check all the boundary constraints. So in the previous class, we started with the white box testing approach. In that, we discussed test adequacy criteria, code coverage, control flow graphs, paths, and looping testing. So in the control flow testing, here we will create the control flow graph for the corresponding code. Using the control flow graph, we will do the testing. So it means that we will create the graphical representation of your project. For the given code, the corresponding graphical control flow graph will be generated. By making use of the control flow graph, we will check by seeing the graph itself, we can understand where we are giving the input, how the input is processed, and how it is producing the output. So we are seeing how the process is going on, and we will try to find out the bugs and errors. In control flow graph itself, it covers 4 major conditions: statement coverage, edge coverage, condition coverage, path coverage, and psychometric complexity. We know very well statement coverage means each and every statement in your program will be checked. Coverage means we have to cover, that is from the first line to last line in your program, we have to check for the correctness. So in the statement coverage, we will cover the entire code or your entire statement in your project. And edge coverage means, so edge means say while creating the control flow graph, we'll have the edge, that is we will represent the process in the nodes, and the edges are used to connect one process with the another process. So the edges, how the flow is happening will be tested. Condition coverage means that various constraints, minimum constraint, maximum constraint. And the various conditions will be tested. Path coverage means while executing the process, the path, the various nodes which are processing your data will be tested. In psychometric complexity, what we will do, we will check the logical constraints, we will check the time complexity as well as the space complexity of your project. So the diagram shows you how we are performing the test adequacy criteria. From this diagram, you can easily understand the various components of your testing process and how it is categorized. So here from this table, you can easily understand which is the major condition checking and what are the subheadings, and each subheading of your testing process, what are the constraints and statements we are covering. So these slides are for your understanding purpose. So in under white box testing, we are mainly focusing on test adequacy criteria, code coverage, control flow graphs, paths, loop testing, and mutation testing. So the control flow graph means we will draw the graph. I think you might have already studied graphs in your data structures. So we'll have directed graph, undirected graph, weighted graph. Graph will be having a number of nodes, and the nodes will be connected through the edges, and the data flowing through the edges are called path. In most of our testing, we are doing both white box testing as well as black box testing method. Why? Because some errors will be easily found through the white box testing. Some errors we need to follow the black box testing to find out the hidden errors. Both control flow testing and data flow testing will come under white box testing only. So we discussed what is control flow graph, why we need control flow graph, and the stages and steps followed in control flow graph. The notations used in the control flow graph is, because it is control flow graph, graph means we'll have nodes, and the node will accept some input and it will produce some output. So the nodes are represented using circles, and there will be arrows which represents the flow of data. So we have different types of nodes. If a node accepts one input, produces two output, means it is a decision-making process. If it accepts one input, produces more than two outputs, means it is multi-way decision-making process, because the actual code is converted to corresponding flow graph. And if a node accepts two inputs and produces one output, means it is an junction point. So two inputs producing one output. So the various notations used in control flow graph is shown in the diagram. So there can be a sequence form of flow graph. Sequence flow means one by one. So if you have 10 nodes, each node will have one input and one output. There will be a sequence of flow, 1, 2, 3, like that. And if it is if then else statement, we need a if condition, then two branching statements, once again, one junction point. And if it is switch case, you will accept some input Then we will go for the decisions based on the cases. So switch case control flow will be presented like this. And if it is an while do statement, we'll do while, do some process, then you check the condition. Do the process once, then check for the condition is called while do statement. And repeat until means repeat the process until the condition fails. So whatever may be the statement, the corresponding statement will be represented by using the control flow graph. Through the control flow graph, we can easily check how the data is flowing, whether it's checking the logic or not, the conditions are verified properly or not, constraints are maintained. So everything can be easily verified by seeing the graph itself. Say, for example, for the control flow graph, we have taken the sample code. The corresponding sample code is represented using the control flow graph. Then we will say each and every statement, the condition assignment operation is represented using one node. If statement is represented using another node. And if condition true means the true condition, false condition. Then branching, then assignment process. So everything is represented using flow graph. So any doubt with respect to control flow testing? Any doubt? Rahul?
No, ma'am.
Navi?
Yeah, ma'am.
If you read the PPT, you can easily understand. Nothing, no complexity, no hidden idea, nothing. Simply, it's direct. Just to read the what is control flow graph, how the graph is generated, what are the different notations used for the given program, how we are creating the control flow graph, then how we are testing. The next topic is called code coverage. Code coverage means our program is made up of n number of statements. So every project will have n number of statements. So in, all the statements in your project need to be tested. So to test the different parts of your project, we are using different types of coverage means covering or checking the entire process. So the code coverage is divided into the following types: statement coverage or line coverage. Statement coverage means each and every statement, assignment statement, execution statement, condition checking statement, processing statement, decision making statement, every statement or line in your project will be tested by making use of statement or line coverage testing method. The second type is decision and branch coverage. Decision means we may use if statement, if else statement, nested if statement, do while statement, while do statement, switch case statement. So those kind of decision making statement or branching statements will be tested by using the branch coverage method. The third one is condition coverage, checking for the condition. If the condition is satisfied, it will repeat the process. If the condition fails, it will come out from the looping structure, minimum constraint, maximum constraint. So all those things will be tested by using condition coverage testing method. And multiple condition coverage means we'll check multiple conditions. Say it may be a complex statement or it may be a mixed mode statement that can be tested by using multiple condition coverage testing method. And decision and condition coverage. So say for example, if it is for loop, we'll check for the condition. If the condition satisfied, then take the decision. Go to the else part or go to the if else if part. So both decision and condition coverage may come in a single statement. Those kind of statements can be tested by using decision and condition coverage testing method. The next type is loop coverage. So we are using so many looping statements. So most of the looping statements are the common, the same type of looping statements are used in all the languages. Say we are using the same if statement, loops, while statement, iterative statement, do while, switch case, conditional operators. Those things we are using in C language, C++, Java, Python, even Oracle, SQL, PLI, whatever may be the language, the same kind of statements are used. So whatever may be, irrespective of the language, we can make use of the looping coverage testing method to test your looping statements. The next is path coverage. Path coverage means how the data is flowing among the various executable statements. Say if you represent your lines of code by using a graph, flow graph, then you can find out the path. Where the input is going, where it is, what is the output, how the output is used by another function. So like that, we can easily trace out the path of your execution. So these are the 7 types of coverage statements, or code coverage statements are categorized into 7 types. First one is line or statement coverage, decision and branch coverage, condition coverage, multiple condition coverage, decision and condition coverage, loop coverage, and path coverage. See, any doubt with respect to the topic? So it's by the name itself, you can easily understand what is what. The thing is, you have to remember the code coverage is having 7 types. Code coverage or statement coverage testing method is subdivided into 7 types based on the type of statement what we are going to test. So the next section we explained each method separately. The first type is statement or line coverage. We know very well it is used to check for the errors and bugs hidden in the statements and lines of your code. We taken a sample program. Here we have two, for example, we taken 2 statements. Here x equal to 1 is an arithmetic assignment statement, e equal to 1 by x is an processing statement. Both are arithmetic assignment operators, both are expressions. So here these 2 statements can be tested by using the statement coverage method. For to represent how the statement coverage is performed, we taken the code and the corresponding flow graph, and we generate the corresponding flow graph, control flow chart for the given code, and for the variables available in the code, here we have the variables like y and abs. So for y, if you give the value as 1, what will be the expected result? What is the actual result? So we will take the sample code, we'll create the control flow graph, and we will assume the values for the variables y. And if you give the value of y as 0, what will be the expected result? What will be the actual result? That you need to remember. You can take any example code, you can take the corresponding flow graph, then assign the values for the variables, check for the actual result and expected result. The same way in the statement coverage, with the same thing, we are drawn the flow graph. If you give for the test case 1, we are giving some inputs and expected output and actual output. Both the expected output and actual output should match. Then there is no error in the project. If expected output and the actual output are different, then there is some logical error. So any doubt in the statement coverage? The next is line coverage. So in line coverage, software developers and testers commonly use line coverage because of its simplicity and availability in object code instrumentation technology. So we can easily check for the line and its any executable line, any processing statement line, and its hidden error by using the line coverage method. All the structural coverage criteria, line coverage is the weakest, indicating the fewer number of test cases. So each and every line is taken for testing. Bugs can be easily occur in the cases that line coverage cannot see. So there may be chances of leaving some unidentified errors. So what is wrong with the line coverage means the most significant shortcoming of the line coverage, it fails to measure whether test simple statement or with the false occur outcome. So while testing the line coverage, we'll check for the each and every line. So if the line is okay, we will not check for the other associated lines. So if it is an if statement, the if part may be working, else part may not work. So we are taking each line at a time. Because of that, we are trying to concentrate on the same line. We are not considering the other interrelated lines. So that is one of the drawback. The next is branch coverage. So we know there are a number of branching statements, true or false conditions, if then else if, do while. All those branching statements will have two branches. If the condition is true, it will branch to the statements followed by if statement. If the condition is false, it will branch to the else part. Here we taken the example A equal to true and B or C equal to false. So if this is the condition, if A, B, C are given the following values, what will be the corresponding output? If A is given 0, B is 1, C is 1, because it is Boolean arithmetic, B and C are 1, but A is 0. So the output will be 0 only. The same way, if A takes 1, B and C takes 0, then the output will also be 0. Because if any one value is 0, the output will be 0 in case of AND operation. The given condition is A equal to true and B or C equal to false. A is true means 1, B or C is false means 0, 0. The same way A is false means A is 0, B or C equal to true means B and C are 0, 0 values. So like that, we will check for the branching statements. The same way we can check for decision and branch coverage, both decision statement as well as branch coverage statement. Here we taken the example, we are taking a decision based on the branching. The line of code is if y is greater than or equal to 0, then y equal to 0, else AB is equal to y. So the corresponding flow graph is drawn for our understanding purpose. Then we will identify the values for y, what is the expected result and what is the actual result. That should be identified. Say if y value is 0, the expected result is 0 as well as actual result also 0. If y equal to -5, we are getting the expected result as 5, but actually we are getting -5. Here the expected result and actual result are mismatching. So there is some logical error in the code. The same way, condition coverage means we taken a condition statement. For the given condition, x is less than 10 and y is greater than 20. If the condition is true, then it will call the function z equal to f over x comma y. So here we are checking a condition. Based on the condition, the branching will occur. For the given code, we are drawn the corresponding flow graph as it is from the code. Then here we have two variables x and y. If we give the x value as -4, y equal to +2, then the expected result will be +3. And if you change the value of x equal to +12, y equal to 3, then the expected result will be correspondingly it will change based on the function what we are executing as FOO or FIE. So any doubt with the condition coverage, we will take some condition and we will try to test for the hidden errors in the condition. Got the idea what is condition coverage?
Yes, ma'am.
The next thing is branch and condition coverage, both branching as well as checking for the condition. Here there may be chances of in our project having both condition and branch combination. Use a model of the program flow where each combination of the inputs for the decision and condition must be tested. In order to check if the branch is covered, for each test case, specify inputs of the component and the expected outcome of the test case. So we'll take the branch and condition combination statement and we will assume the inputs and the expected output. Both will be noted down in the test case itself. Then we will give the actual input to the project and we will check for the output from the project. If both the expected result and the actual output both are matching, no error. If they are mismatching, no, there may be hidden errors. So from this example, you can easily understand. Here we have multiple conditions. If x is less than 10 and y is greater than 20, one condition. If the condition is true, function foo will be executed. If the condition is false, FIE will be executed. So for the given code, we are drawing the corresponding flow graph. Then we tabulated the values based on the test cases 1, 2, 3. For the test case 1, we are assuming x is less than 10 is true and y is greater than 20 is true. If both the test cases are true, then the expected output will be true. And the same way, if you assume test case 2 as true false, the result will be false because we are using the condition as AND operator. If both are true, then only the result will be true. If any one is false, the result will be false. So here we are checking both multiple condition as well as the flow of actions. For the same multiple condition coverage, we take another example. Here we are taking int x, int y, Boolean return value. If x is less than 10 and y is greater than 5, return false, else return false, and return the return value. So for this given program, we are drawing the corresponding flow graph. Then for the test cases, we'll give the combination of values, false, 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 true, true, false, true, true, and we will note down the expected result and the actual result. If both expected result and actual result both are matching, then the code is free from bugs. If both are mismatching, there is some hidden error in the logic. So any doubt with respect to multiple condition and branch coverage?
No.
So the next thing is loop coverage. This loop coverage also we discussed in the previous class. We know very well, we are using a number of looping statements like for loop, while loop, do while loop. The same way we are using other iterative statements like the switch case and conditional operators, nested functions, recursive functions. Like that, we are using a number of iterative process. So those kind of looping statements can be easily tested by using loop coverage testing method. So the loop coverage can be easily represented by using the flow graph. So we are drawing the flow graph. We will starting from the first, the process A starts, then it goes to process B, and there is a loop between B to A again. Then it goes to the process C, then process D. From again we have a loop from D to C. So that is a simple looping statement. There may be chances of getting the combination like concatenated looping coverage. We start the process, process goes to A, then it goes to B. From B to A, there is a looping coverage. Again, then it goes to C, then it goes to D, again it goes back to C. Here we concatenated two processes, A, B and C, D, and both A, B and C, D are having repeated looping statements. Concatenated means adding of two different functions put together. And here we have nested. Nested in the sense we have the inner loop from C to B and outer loop from B to A. So once the inner loop is completed, then it will come out to the outer loop. So it means that it is a nested or two for loops nested inside. And here the fourth one represents the unstructured looping statement. The process starts from A, then it goes to B, then it goes to C. Again, there is a looping from C to A. Again, from B to D, there is a recursive looping statement. So it is unstructured. It is not nested. It is an unstructured looping coverage. So like that, we will get different combinations of looping statements in our projects. Those kind of looping statements can be easily tested by drawing the corresponding flow graph and giving the inputs and checking the constraints and how the data flows among the various paths. So here they given you an explanation about what is loop coverage. We may have nested loops, starts at the innermost loop, set all other loops to minimum value. So we have innermost loop B to C and outermost loop A to D. Conduct simple loop test for innermost loop and add other tests for outer range of or exclude the values. Continue until all loops have been tested. So the inner loop has to be tested first, then the outer loop will be tested. Then the process will end, the entire process has to be tested. And here the concatenated loop means the loop is independent. The first loop A to B is independent one, C to D is independent one. But both are, once the first loop is over, then the second loop we are getting, both are concatenated, both are added together. So this is an example for concatenated looping statement. Unstructured loops, whenever possible, this class of loops should be redesigned to reflect the use of structured programming constructs. Here, we don't know whether the loop will end or not, because A to C to A, there is a loop, again B to D, another loop is there. We cannot able to differentiate which is innermost, which is outermost. So it is unstructured one. The same. So any doubt in the loop coverage? So far we discussed statement and line coverage. Then we discussed condition coverage. Then we discussed branch coverage. Then condition and branch coverage. Then loop coverage. So any doubt? You should remember in control flow testing, we have 7 types of testing methods. The 7 types are statement line coverage, that will cover the statements and lines in your code. Decision and branch coverage testing, condition coverage testing, multiple condition coverage testing, decision and condition coverage testing, loop coverage testing, then path coverage testing. So the 7 types you should remember. And any example you can make use to explain the concept.
Okay.
So the next subheading is called path testing, or we will call it as basis path testing. This path testing will also come under white box testing approach. So what is path testing means? The objective of path testing is to ensure that the set of test cases in such that each path through the program is executed at least once. So whenever you write any project, each and every path in your project should be tested once, so that if you are not at all, you are giving the input in such a way that it tests only a particular path, the other path, else path is not tested, then the errors in the else path will affect your complete project. So while testing your project, you should test in such a way that each and every path in your project, like each and every lines of code in your project is tested. The starting point for path testing is a program flow graph that shows nodes representing program decision and arcs representing flow of control. So we'll have the nodes that represents the program decision points, and the arcs or the edges represents the flow of control. Statements with conditions are therefore nodes in the flow graph. Each and every statement in your project is represented in the flow graph of your graph. In path coverage, a path is a sequence of branches or conditions. A path is, say if A is greater than B, then A is 1. Then else A is 0. So A is 1 is one path, A is 0 is another path. A path corresponds to test cases or set of inputs. The code coverage testing branches have more importance than the blocks they connect. So each and every set of inputs needs to flow through a particular path. Bugs are often sensitive to branches and conditions. In the path coverage, we have independent paths and dependent path. So what is independent path means? A path is a sequence of branches or conditions. A path corresponds to test case or a set of inputs. Code coverage testing branches have more importance than the blocks they connect. Even the bugs are often sensitive to branches and conditions. So each and every independent path in your project need to be tested. It introduces at least one or new set of statements in the or new condition. When stated in terms of flow graph, an independent path must move along at least one edge that has not been traversed before the path is defined. So the input should be given in such a way that the entire path, both the paths in any branching statement should be tested. Already we discussed loop testing. In loop testing, we have simple loops as well as, say, in the loop testing, for the given flow graph, we can easily identify how many paths are there in a given flow graph. Say for example, we have an graph with a number of 6 nodes. And the nodes are ordered in such a way that 1, 2, 3, again 3 is having the branches 4 and 5, and 2 is connected with the branch 6. So for the given graph, we can identify how many paths are there. So here, for the given graph, the path 1 to 2, 2 to 6 is one path from starting node to end node. That is, we have the grandchild node, grandchild nodes or leaf nodes called 4, 5, 6 without any branches, or called leaf nodes or grandchild nodes. And 4 and 5 is connected with the parent node 3. Again, the parent node 3 is connected with the grandparent node 2. Again, the one is the root node. So here, according to the source node or root node to the leaf node, we get the path 1 to 6 is one path. Again, another path 1, 2, 3, 5, 2, 6 is another path, because we have a branch from 2 to 5 to 2, 2 to 6. Again, we have one more path from 1 to 2, 3 to 4, 4 to 5. Again, 5 to 2, 2 to 6. So that is another path. So here we are getting 3 different paths. You got the idea how we are identifying the path? Path means the route from source node to the destination node, or source node to the leaf node. So for the given flow graph, we have 3 paths. Any doubt in what is path and how we are creating the path?
No, ma'am.
So based on the path, and we are calculating the psychometric complexity. Yeah, can you able to see the PPT, psychometric complexity?
Yes, ma'am.
Yes, ma'am. Yeah, psychometric complexity is a software metric that provides quantitative measure of the logical complexity. So how we can measure the complexity or logical hidden errors in any program? That can be measured by using evaluating the complexity of your project. So the complexity of the project increases by if you have n number of the dependencies high among the functions, then the complexity increases. If the functions are independent and there is less coupling and more cohesiveness, atomicity is maintained, then the complexity will automatically reduce. When used in context of basis path testing, the value computed for psychometric complexity defines the number of independent paths in the basic set of program and provides us the upper bound for the number of tests. So as we discussed, the complexity of your project increases if the number of dependencies is less. If the independent paths are there, if the more number of independent paths are there in your project, then the complexity will reduce. If there is more dependency among the path, then the complexity will automatically increase. Say for example, we'll take a graph, flow graph. Here in the flow graph, we can easily, by seeing the notation itself, we can easily understand we have the processing assignment process represented in rectangle box. Then we have diamond symbol, a decision making statement. Then there are two branches, yes or no condition. Again, we are checking one more condition using diamond symbol. Then we are checking based on the second condition, we are taking two branches. Again, it coming back to one more condition checking, diamond symbol. So here the complexity of the thing is there is 4 decision making statements. So we have vertices of graph is 4. How we can measure the psychometric complexity means for the given flow graph, we will take the program, corresponding flow graph will be drawn. For based on the flow graph, we can identify the path. So from the path, we can identify, say next for the given example, we derive the independent path. Here, how many independent paths are there means, we have the independent path from 1 to 2, 3 to 3 to 6, then 7 to 8. From source to destination, we have one path from 1 to 2, 3 to 4, 6, then 7 to 8. That is one path. Another path 1 to 2, 3 to 5, then 7 to 8. One third path is 1 to 2, 4 to 7, and 8. That is third path. Fourth path is 1 to 2, 4 to 7, then 2 to 4. Again, then it comes to 7 to 8. So we are getting 4 independent paths. Finally, we derive the test case to exercise those paths. From the paths, we can easily identify the psychometric complexity of this project is 4. Say for example, we'll take another sample example. We'll take an state Java code, public void how complex I equal to 20 while I is less than 10, system out println will print the value of I. And if I divided by 2 double equal to 0, then print even. So here we are checking whether the given input is odd number or even number. For the given code, we can draw the flow graph and we can identify how many decision making statements are there and how the branching is going on. So from this, for the given code, the corresponding flow graph, we can identify there are 3 possible paths. The 3 possible paths can be from source to the diamond symbol, then processing, true condition, then exit. The second one, false condition, exit. Another condition, go back to the decision making and exit. So the V of G is 3 here. So here you need to understand what is path testing and how the path testing can be tested by creating the flow graph for the given code. Here, based on the path testing, we are getting a concept called basis path testing. The basis path testing is a white box testing method. Here we use the flow control flow graph, and we can easily compute the psychometric complexity by using basis path testing and determine the basis set of linearly independent paths. So we need to identify how many linear independent paths are there in our project, then create a test case for each basis path, then execute the test. So those are the steps followed in any basis path testing. For our understanding purpose, we taken a flow graph. Here we will identify, for the given flow graph, we need to identify which is the baseline and how many decision points are there in our given flow graph. So create the basis path testing by creating the path 1 to 2. So from the left hand side, you can easily identify there is one decision point, decision making statement 1 at the place A. There we will take the branches B and C. Again, we have one more decision making at D. Based on the D, we will take 2 branches, decision 3 and decision 5. Again, 3 is having 2 branches. Decision 4 is having 2 branches. Again, 5 is having 2 branches. 6 also having 2 branches. So based on those decisions, we are reaching the destination. We have the source at A and destination point at S. Can you able to understand the graph, flow graph in the left hand side? Naveen? Any doubt in the flow graph given?
No, ma'am.
So we have a flow graph with the n number of nodes up to A, B, C, D, O, P, Q, R, S, up to S. Here we are taking the node A is the source node and node S is the destination node. So we can easily identify wherever we are getting junctions, 2 inputs, 2 outputs. So that is an decision making point. So decision making point, decision 1, 2 branches. Decision 2, again 2 branches. Decision 3, again we are branching to 2. Decision 3, 4, 5, 6. We have 6 decision making points. So for our understanding purpose, in the right hand side, they given, we are going back to decision point 1. So in the decision point 1A, if you take the decision as your choice is B, then you will go from B to D. And if you take the decision as C, A is having the decision making power of B or C. If you take the decision as C, then you go to D, then you go to the branch E. Then you will come to EG, that particular path. The same way in the decision making point 2, if you take the decision as F, then you will go back to F, I, L, O, or S. So that is your path. The same way, if you take the decision as decision point E, decision 3, if you take the decision as E, then if you take the branch as H, then you will have the path from H, K, M, Q, S. So based on the decision point, which choice you choose, you will have your path. Say before joining college, you may have the decision. You want to go with engineering or you want to go with medicine. If you taken the decision as going with engineering, after your graduation, you are coming to MTech. If you taken your decision as medicine, after your MBBS, you might have gone to clinical clinics, or you may gone to MD. Again, after your PG, if you take the decision as research or a job, you'll go for job or you will go for PhD. So based on each decision point, we have n number of choices. So based on the choice which you are making, your path will differ. You got the idea? Any doubt in the basis path testing? So we are choosing a particular path based on the decision what we are making. Any doubt?
No, ma'am.
According to the graph, we have 6 decision making points. In any point, if you take another path, you need to face different nodes. If you take a particular choice A, you will face different path. If you take the choice as B, you will face different path. So accordingly, we are getting the following 7 path. So if you take the decision as A, then you take the decision as B, then you will get the path as D, E, G, K, H, G, K, M, Q, S. At the point A, if you take the decision as C, you will get the path 2 as D, E, G, K, M, Q, S. The same way in the point decision making point R, if you take the choices R, then you will get the destination as yes. So the path differs based on the choices you make in your basis path testing. And our aim is to cover the entire node at least once by following a particular path. We should not leave any node untouched. You got the idea?
Yes, ma'am.
So we will get the code. For the given code, we'll go for the flow graph. And in the flow graph, while making use of the basis path testing, our aim is to visit each and every node in your flow graph at least once by making a particular decision path, so that each and every node in your flow graph is tested once. And based on the decisions we make during the decision making point, we will get different paths. And where we can make use of this the basis path testing means, so the control flow testing is the basis of unit testing. Usually the basis path testing is method is used along with unit testing method. While checking each and every unit or function of your project, we will go for basis path testing, so that each and every statement is tested once, or each and every node is visited once by using some test case. And we will get all the combination of paths in such a way that each and every path is tested and no hidden errors are left. It should be used for all modules of the code that cannot be tested sufficiently through reviews and inspections. If you are not conducting proper reviews and inspections during your testing process, you can go for unit testing method to check all the lines of code by using basis path testing, because the basis path testing covers the entire range of code. It is testing each and every node in your project and each and every path in your project. For the given code or for the given function, we'll create the corresponding control flow graph, and by using basis path testing, we'll check all the decision making points and we'll cover the entire path of your project. And the main applicability and limitation of this basis path testing is, its limitations are that the tester must have sufficient programming skills. So if you know the programming skill, if you know if the project is written in Java, you should be well known. You should have the programming constructs of Java programming language. Then only you can check each and every line of your project. Control flow testing can be very time consuming because all modules and basic paths that comprises the system. So each and every path, each and every node in your project is tested. So it will take long time to test each and every path. So that is the only drawback. And the advantage is it can cover the entire project line of code in your project. The drawback is it is a time consuming process because we are checking each and every line, each and every path of your project. So far we discussed code coverage, line coverage, decision making coverage, branch coverage, multiple decision coverage, path coverage, all those things. Then we discussed control flow graphs. Then we discussed path testing and basis path testing and loop testing methods. The last topic is mutation testing. What is a mutation? I think you might have studied mutation is a biological word. I will create the mutant. Say if the cells are muted, we are getting cancer. The same way in the COVID also, we are getting so many mutant varieties. Initially we had COVID-19, then we had Delta, Alpha, Delta, then Omicron. So like that, we are getting so many varieties of the same virus. The same way in mutation testing, what we will do, mutation testing is another approach to test data generation that requires knowledge of code structure, but it is classified as fault-based testing approach. So here we will create the fault code or mutant code for the given program. Then we will perform the testing. So it is called fault-based testing approach. It considers the possible fault that could occur in a software component as the basis for the test data generated and evaluation of testing effectiveness. The mutation testing makes two major assumptions. While performing the mutation testing, we will have two assumptions. The first one is the component programmer hypothesis. So here the competent programmer hypothesis is, it states a competent programmer writes programs that are nearly correct. We will assume that whatever the program written by the programmer is perfect. Therefore, we can assume that there are no major construction errors in the program. The code is correct except for a simple errors. We assume that the program is almost 90% perfect and there are some hidden errors 2 or 3%. And the second assumption is the coupling effect. I think you might have studied the coupling and cohesion in DBMS, that is normalization. First normal form, second normal form, third normal form. The same way you might have studied coupling and cohesiveness in object-oriented programming, OMT, object management techniques. The same way here also in mutant testing, what we are doing, we will give importance to the coupling effect. This effect relates to questions a tester might have about well-mutated testing can detect complex errors since the changes made to the code are very simple. So we'll create the mutant code, then we'll go for testing and we will try to find out the maximum errors because the mutant error code will have always defect. The coupling effect hypothesis that test data sets that detect simple types of faults are sensitive through detect more complex types of faults. So by using this mutation testing, we can easily identify the complex errors easily than the simple errors. So based on the assumptions, what is mutation testing means? It is a type of software testing where we mutate or change the statements of the source code and check for the errors hidden in the program. This type of white box testing method mainly used with along with the unit testing process. So the mutation testing is an unit testing method where we will mutate the program and we will find out the errors. The changes in the mutant program are kept extremely small. We'll create a small number of changes in the project, and the goal of the mutant testing is to assess the quality of the test cases. So by using this method, we can easily assess whether the test cases are perfect or not. The method is also called fault-based testing strategy as it involves creating fault in the program. So we'll create our own fault, then the error program will be tested to identify more errors in the hidden errors in the project. So here, say for example, the mutant testing, T is said to be the mutation adequate for program P. So we'll take the variables. P is our program, T is the test set, and PA is the mutant program where an element T in T such that PA of T is not equal to P of T. So we'll take three variables. P is our original program, PA is our mutant program, T is the test set. Our aim is to PA of T is not equal to P of T because P of T is the original program and PA of T is the mutant program. The mutant program and the original program will not be same. Say for example, constant replacement. The mutant testing can be done by using the following methods. The first one is we can replace the constant. If you are using some constant, that constant can be changed, or arithmetic operation replacement. The arithmetic operations can be modified, or data statement alteration, or statement deletion, and logical operator replacement. So the mutant programs can be generated by using the following 5 techniques. We have the original program. The mutant program can be constant replacement, arithmetic operator replacement, data statement alteration, statement deletion, and logical operator replacement. Say from the diagram, you can easily understand we have the original program. We will introduce some fault into the original program. We are getting the mutant program. You got the idea? So we are finding the vaccination for COVID by taking the virus itself. We are killing the virus, and the same dead cell of the virus is used to create the antibodies. You got the idea? Ahmed, any doubt? What is original program? What is mutant program?
No, ma'am.
So from the diagram, we can easily understand how the mutation testing is performed. We are taking the original program. Then we are introducing some fault into the original program. By adding the fault with the original program, we are getting the mutant program. Now the mutant program is tested by using the test cases. And we are trying to find out the, we add whatever error we introduced that we know very well. Through the fault, we can identify other hidden fault. So the diagram from the left hand below, we can see we have the original program as well as mutant program. Test cases are applied to both the original program as well as to the mutant program. Now the original program and mutant program should produce different results. If both are producing the same result, then there is error in our original program. So if you understand from this diagram, you can the mutation testing is nothing. Everything is explained in this diagram itself. We will take the original program, add some fault. That is explicitly we will add some fault to the original program, and we will get the mutant program. Now we will create the test case. The test case is applied on both mutant program and the original program, and we'll check for the result. Now the original program and the mutant program should produce different results. If both are producing the same result, then the original program is also having some error. So in mutation testing, we are following the following 5 steps. The first step is faults are introduced to the source code by the programmer. Each mutant should contain at least a single fault. So that is the first step. We'll take the original correct program. We'll add some fault into the program, and each and every program should have at least one fault. The second step is the test cases are applied to the original program and also to the mutant program. So we'll apply the same test case to the original program as well as the mutant program. A test case should be adequate and it is tweaked to defect faults in the program. In step 3, what we will do, compare the results of the original and the mutant program. Step 4, if the original program and the mutant program generate the same result, then there is some hidden error. If they produce a different output, then the mutant is killed by the test case. While applying the test case to the mutant program and original program, the mutant program should produce false result. Then the program is perfect, the mutant is killed, only we will keep the original program. In step 5, if the original program and mutant program generate same output, if both are producing the same output, the mutant is kept alive. In such case, more effective test cases need to be created that kill all mutant. If both the mutant program and the original program produces the same result, it means that the original program is fault. Then we will create effective test case to find out the hidden errors. Any doubt with the 5 steps followed?
No, ma'am.
These are the 5 steps. Any doubt? It is very simple concept. You understood or not?
Yes, ma'am.
Okay.
So anyone of you can explain? What is Can anyone explain what is mutant testing? Ahmed?
Yes.
Yeah, can you tell me what is mutant testing? Yeah, from this example, you can easily understand. See how to create the mutant program means a mutation is nothing but a single syntactic change that is made to the program statement. We'll create a small syntax. So you know very well, every program will have its own syntax and semantics. Syntax means the rules and regulations we need to follow while creating any executable statement. Semantic means the literal meaning behind the executable statements. So in for loop, for I equal to 0, I less than 10, I plus plus, there is no semicolon. If you put one semicolon, that is a syntactic error. The same way, while calling a function or while executing an while defining the function, we will not use semicolon. While calling the function only, we'll use the semicolon. So if you change the syntax, then it will create syntactic error. Say here, the original program is if x is greater than y, print hello, else print hi. So that is correct program. How we are creating the mutant program means, instead of x is greater than y, we are creating x is less than y. Here the logical expression less than is changed. Instead of greater than, we are changing it to less than. If the less than and greater than is interchanged, then it should produce the mutant program should produce wrong result. After changing the syntax also, if it is both are producing the same result, means then the original program is logically wrong. You got the idea? Naveen, any doubt? We have the original program, then we have the mutant program. In original program, we are using the statement if x is greater than y. In mutant program, we are using the statement x is less than y. X is greater than y and x is less than y. That is totally different. Now, when you apply the test case with the original program and mutant program, it should produce different result. If both produce the same result, then the original program is having logical error. And how the mutant program, how the mutate program can be generated means, we can generate we can make use of operand replacement operators. Here we can replace the operand and operators. Replace the operand with another operand, x with y or y with x. So instead of x and y, we can interchange. Instead of x is greater than y, you can say y is greater than x. Or instead of x, you can give some constant value. We are giving 5 is greater than y. So in this way, by making small change in your line of code, we can create the mutant program. See in the previous example, we interchanged the symbol x is greater than y to y is greater than x. So here x is greater than y and here x is less than y. So this is original program, this is mutant program. Here we are replacing the operator and we are replacing the operand. Here the variable, instead of x is greater than less than y, we are using x is greater than y. Instead of x, we are using the constant value. So this is also a small mutant. The same way, statement modification operators. We can change the operators or the statements. Programmatic statements are modified to create mutant programs. Example, delete the else part of the if else statement. So in your project, if you have if else statement, delete the else part. Then you check how it is working. Delete the entire if else statement to check how the program behaves. So in the function, you can delete the entire if else statement. Then you can check for the process. You can create the automatic mutant programs and you can do the testing automatically by using the following tools. We have a number of open source tools and paid licensed tools available to create the mutation, to perform the mutation testing. Mutation testing is extremely time consuming and complicated to execute manually because we are changing the code and we are changing the syntax. So it may complicate the testing process. To speed up the process, it is advisable to go for automation tools. Automation tools reduce the cost of testing as well. So we have the list of following automation tools: Ninja, Turtles, and it is used to test the .NET mutant testing tool. The same way we have Mutation. It is used to check the PHP mutant testing framework. We have Gesture mutation testing tool for Java. So these are the open source and testing tools available to perform automated mutation testing process. So in the mutation testing itself, we have three types, subheadings. The three major subtypes are statement mutation, value mutation, and decision-making mutation. Statement mutation means the statement will be changed. It may be if x is greater than y, we can change it to y is greater than x. Or it may be value mutation means instead of using variable, you can make use of constant. Or instead of using variables, you can go for other related variables. And decision making mutation, you can go for control statements are to be changed. Instead of using do while loop, you can go for while do loop. Instead of using for loop, you can go for switch case. So like that, we will change the decision making statement itself. So the three types of mutation testing are statement mutation, value mutation, and decision making mutation. And in mutation testing, we are calculating mutation score. The mutation score MS of PT, where P is the killed, P is the original program, and T is the test case. So we already discussed now, we used some parameters. We used the parameters now, where T is the test case and P is the given original program, PA is the mutant program. By using those parameters, you can evaluate the mutation score. How we are evaluating the mutation score means MS of PT, where P is the original program, T is the test case, is equal to number of dead mutant divided by total mutant minus number of equivalent mutant. So dead mutant means if the original program and the mutant program both are producing different result, then we will kill the mutant program. So how many case mutation testing is successful, that is taken as number of dead mutant. And total mutant means, say if you created 10 mutant program, 10 will be taken, 10 mutant. And the number of equivalent mutant, the corresponding equivalent mutant will be taken. Equivalent mutants are discarded from the mutant set because they do not contribute to the adequacy of the test set. So the mutation score is equal to killed mutant divided by total number of mutant into 100. Got idea? Any doubt with this? Here you need to understand what is mutation testing, how the mutant program is generated, and what are the three types of mutant testing, and an example code. The advantages and disadvantages of mutation testing is it is powerful approach to attain high coverage of source program. Mutation testing brings a good level of error detection in the software developer. This method uncovers ambiguity in the source code, and customers are benefited from this testing by getting most reliable and stable system. So it's mostly used by many of the testers to uncover the hidden errors. And the disadvantages are mutation testing is extremely costly and time consuming because we are changing the syntax and semantics, so it will definitely create errors. Each mutation will have same number of test cases than that of original program. The large number of mutant programs may need to be tested against the original test shoot. For each and every test program, we are creating the mutant program and we are performing. So that will complicate the process, and we need more test cases. As this method involves source code changes, it is not at all applicable for black box testing. So it is not in black box testing, it is in white box testing method. Why? Because we are changing the code, then we are performing the testing. So the programmer or the developer can alone perform the testing process. So any doubt with respect to mutation testing?
No, ma'am.
We have the following simple topics. So you might have come across the following topics in general. You may hear the test execution, building the test case, life cycle of defect. Often we use the keyword defect. Defect means some fault, defected products. Or so with based on the defect, we are getting the following topics like defect tracking, defect detection stages, defect types, and defect severity, defect analysis and prevention. So based on the testing, our idea behind testing is to test execution is to identify the defect. While creating the test data, we'll apply the test data on the software and we'll identify the defects hidden in the software. So the defect tracking is a process. Defect detection stages, it's having life cycle as well as stages, and we have a number of defect types, and the severity of the defect need to be identified, and we need to perform defect analysis and preventive process. So they are all simple and basic. It is like theoretical aspects. So if you take what is defect management means, the idea behind defect management is to find, handle, and report defect by using standard techniques. So the idea behind software testing and defect management is to find out the hidden errors, understand the defect cycle. Simply, we cannot identify the defect. We cannot say this is defect, or we cannot say this is an error. It's having a life cycle. So we need to first identify, then we have to check, inspect, then we have to prove, then we have to generate the report, then we will prove that it is a defect. So a defect is nothing but undesirable state. If you are getting an hangout, if you are not getting the perfect result, if it is not processing, if it is not responding, so like unexpected or exceptional conditions are called defect. It causes consumer user satisfaction. So if it is not producing the expected result, no satisfaction, then it is a defect. Concern about the quality of application and the test. We will take some application and we'll check for the quality. If the quality is not up to the mark, then it is a defect. Inconsistency in behavior of the software. If the software is not behaving as per the expected norms, then it is a defect. Condition in the software product which does not meet a software requirement or end user expectations is called a defect. So the methods for preventing the programmers from introducing bugs during development is, so these defects can be easily identified by using program techniques like software development methodologies. If you follow a particular methodology, we can avoid most of the errors because the methodologies provide you a systematic way to do some process. So that will eliminate many of the unexpected errors. And if you go for peer review or code analysis, during that time we can identify the bugs, and the root cause analysis, effect of defect, that can be the root cause analysis. Will try to find out the defects from the root cause. Based on the defects what we found, we can classify the defects. Defects may be classified in different ways under different schemes. The various methods are requirement related defects. If the requirements are not fulfilled, then it is a requirement related defect. It can be based on functional defect or interface defect. Functional requirements are not met means it is a defect. Design related defect. During the design stage, if the correct algorithm is not chosen, modules and interface is not properly designed, system interface is not made, user interface is not implemented, then it is a design defect. During coding, we have coding defect. If the variables declaration part initialization is not done properly, database related defects are not addressed, database is not designed properly, normalization is not done, constraints are not fixed, commenting and documentation is not done properly, then it is coding defect. The same way during testing process, if the test case is not designed properly, environment is not tested, tools are not used properly, then it comes under testing defect. And during the work product, so the final Usable product is called, end user product is called work product. The output, the final output is called work product. So in the work product, we may get the following defects like system study document is not properly done, functional specification document is not designed, architectural design document, a detailed design document, source code defect, and test plan test case is not done properly, user documents and operating manuals, user manuals are not prepared well, then those things also come under work product defects. The same way we can categorize the errors, say error wise types. While doing the project, we may get these kind of errors or defects. Say the comments are not properly done, computational errors not addressed, data errors, database errors, missing design, incorrect design, boundary conditions not checked well, logical errors, navigation errors, performance errors, ambiguous requirements, and standards not maintained, system errors, typological errors. So those are some of the, and the status wise errors like open, close, cancelled, those status we are not getting. They are all come under the defects. The same way, defect management process must have the following characteristics and principles. So what are the major principles followed during defect management means, primary goal of defect management is to prevent the defect. Defect management must be risk driven. So we are ready to take the risk to identify the hidden bugs. Defect prevention must be an integral part of the defect process, and defect tracking must be automated, and integration must be used to improve the process. Defects are caused by imperfect fault processes. So these are the steps we need to consider. And how we can identify the software defects means, different techniques are used to identify the defects. Say we can make use of the static techniques like if the statements missing requirements are mentioned, design defects, derivation from standards, inconsistent interface, non-maintainable code, insufficient maintainability. So these are the major causes of identifying the defects. If you take the defect management process, once you identify the defects, you need to manage the defects in such a way that can be easily eliminated. So the defect management process, or we'll call it as fixing the root cause defect. Once you found the defect, you need to fix it. How we can fix? Fix means it must include appraisal of your defect finding process. Once you found the defect, an appraisal form should be filled, software development process and the actions initiated to close the defects and strengthen the product process so that defects are not repeated again and again, and we can do the corrective action and preventive action. The corrective action, preventive action, it includes a defect naming, resolution, developer have acknowledged the value defect, acknowledge the valid defect, and there is a resolution process. How the resolution process start means, the resolution process should fix the defects and it should produce the corresponding correct program. What are the types of defects in software testing means? It may be due to arithmetic defects, logical errors, syntactic errors, multi-threading errors, interfacing errors, and deformance defects. And the defect detection and tracking is having its own life cycle. We will call it as life cycle of defect and defect tracking. It's having the life cycle stages like requirement study, then we'll go for design, implementation, testing, and release management. So requirement study is the first step, design is second step, implementation is the third step, testing and release management is the fourth and fifth step. So this can be categorized into defect prevention stage and defect detection stage. If you found the defect during the requirement study and design implementation, there itself we can do the changes and correction, we can prevent the defect. Once it goes to testing and implementation, we need to rectify. So once the product is developed, we cannot do anything. If it is in analysis and design stage, that stage itself, if you found the defect, we can rectify. Once it is implemented, then we need to identify the defect and prevent the We need to identify the defect and detect and eliminate the defect. If you take the defect management process, that is fixing and root cause defect, we need to follow the following steps. The first step is prioritize the risk, whether it is high priority, low priority, or medium priority, according to the type of the risk, very critical, major, or minor defect. First, we need to categorize and prioritize the defect. Then schedule the fix. So then you have to schedule some time and method to fix the defect. Then fix the defect. It corrects and verifies one or more deliverables required to remove the defect from the system. So we have to take some preventive action in such a way that the defects can be fixed and eliminated. A test data checklist should be viewed, enhanced, so that the future this defect would be caught earlier. So once you find the defect, you need to follow some steps to fix the defect. Then report resolution. Once the defect have been fixed along with other information like nature of the fix, when and how to fix it will be released. So once you found and identified, you need to eliminate that, and you have to fix it, and you have to create the report based on the eliminated risk. Then deliverable baselining, identify key deliverables, defines standards for each deliverable, process improvement, and management reporting. So these are the steps we need to follow while identifying and removing the defects. So any doubt so far, what is defect, how we can, what is the life cycle stages of defect, and how we can fix and eliminate the defect? And the last topic in this module is defect prevention process and defect fixing. How we can prevent and fix means it's having the following steps. Say in the first stage, identify and categorize critical risk due to defects in the software. In the second stage, estimate the expected probability and or impact of the such defects, whether it is normal or abnormal one. Then in the third stage, minimize the expected impact of probability by corrective actions, and preventive actions. So these are the major steps through which we can eliminate the defect by using defect fixing process. So here we need to consider the following steps and points. Identifying the critical risk, understand the critical risk facing the project or system. Missing a key requirement, vendor supplied software does not function properly. Performance is poor and unacceptable. Critical functions of software that does not function properly, hardware malfunctioning. So if those kind of defects are there in your project, that should be only we can fix the software defects. If you are having any hardware defects, that need to be fixed by the hardware professional. Only the software requirements, functional requirements, coding, and implementation bugs are there in your project that can be easily prevented and eliminated. But if system errors, hardware components errors, interfacing errors, that cannot be eliminated. So any doubt? So the following are the steps in defect prevention. So our once you found the defect and you eliminated, you need to prevent the defect. What are the steps we need to follow to prevent the defect means in software defect prevention? Five general activities to defect prevention are software requirements analysis, division of defects introduced into software by phase. So during the requirement analysis itself, if you found the bugs or defects, you can easily eliminate and change it. And during the review meetings, we can identify self-review and peer review meetings. You can identify the defects. Defect logging and documentation. Whenever you found some defect in any project, that should be documented. Logbook should be maintained. And by making use of root cause analysis and preventive measures, the determination by using those techniques, we can easily identify the root cause, error and defect, and it can be eliminated. Embedding procedures into software development process. So if you are using the standard procedures along with your standard methodologies and the quality standards along with your process, that will also easily, through that also we can easily identify and eliminate the defects. The next topic is called minimizing the risk impact on estimated defect. So when you found some defect in your project also, if you cannot able to eliminate the entire defect, but we can make use of some metrics or some measures to reduce the risk. It may be strongly affected by the risk because a problem and how long it takes for problem to become recognized and how long it takes to fix once recognized. Once we found the defect, it takes some time to identify, eliminate and fix the errors. So until that time, we need to follow the following measures. So we have to estimate the risk by reducing the scope of the project and reduce the probability of the risk becoming a problem. So the defect can become a problem or risk in future, so that you need to estimate and reduce the impact if there is a problem. So if there is some problem or risk in your project, you have to measure how long it will affect, how it will reduce the performance, and how we can reduce the performance issues. So those things should be taken into consideration to minimize the risk impact. So from this diagram, you can easily understand the defect life cycle. So we have a new project, it is opened, then assigned, reassigned. During the assignment and the reassignment process, we are trying to find out the defects and fix it. And once it is fixed, it is verified whether it is eliminated or not, then it is closed. So these are the steps followed in defect life cycle. So you identify a new defect, then open the new defect, assign and reassign the defect so that it can be eliminated, fix the defect, verify whether the defect is eliminated or not, then close the defect process. The same way, we can have the new defect in your project. You are identifying a new defect, then open the defect, assign the defect, you check whether the particular module is very important or not. If you can able to eliminate, you try to eliminate the defect. If you cannot able to eliminate, remove the corresponding code and rejected and defined. Then you go for the testing, we check whether it is eliminated. Bug not important, we will check whether bug is important or not important. If it is not important, then it is deferred, then it goes to bug may occur in future also. To eliminate the bug, we will follow the following steps. If the bug is not a bug, and we will close the bug. If it is a serious one, what we will do, tester finds bugs is not fixed yet, and developer fix the bug, tester checks the bug is fixed or not. If it is an important one, you need to eliminate the bug, then we will go to the, then we will close the bug. So these are the steps followed in any defect life cycle process to eliminate the bug. Once the defect is found, we are eliminating the bug by using the methods and the methodologies. So during that bug removal process, we need to follow or we need to create a report. In the testing end of the testing also, we are creating the testing report. The same way, in the defect identification and removal process, during the software defect removal and management process, you need to create an defect report. We have to follow the template and report. We have to generate a report. In most companies, a defect reporting tool is used, and elements of the report can vary. However, in general, a defect can consist of the following elements. Any defect report should have the following components or elements. So it should have the defect ID, project ID, where the defect is found, and the product ID, a release version of the product, module of the particular project, detect built version, and a summary of the project, description of the defect, steps to replicate the defect, actual result, and the expected results. So these components should be mentioned, or these elements should be mentioned in your defect report template, so that it can be used in future to eliminate the same kind of defects. And other components are, it should have the attachments or enclosures based on the defect, and the remarks, concluding remarks, defects severity, how it will affect the entire process, defect priority, reported by, assigned to, status of the defect, and fixed build version of the defect. So these components should be present or mentioned in your defect report template. And the last topic is estimate the expected impact of the defect. So if you found some defect in your software process, before eliminating or before removal process, we have to estimate the impact, how the defect is going to affect your entire project. How we can estimate the impact means, and the ways to handle the risk is accept the risk as it is. So if you are facing some risk, you should take only, there are only two choices. One is accept the risk as it is, or bypass the risk. Bypass means just you will come out from the risk and you will take another path. So in minimizing the risk impact or probability, minimize the problem due to risk happens in the following manner: eliminate the risk, mitigate the risk, detection ability improvement, and contingency planning. These are the steps we can make use to minimize the risk. Or you can, risk is important factor in defect management. Defect indicates a probability that some unplanned event or a user interaction with the system or environment problem. So if you are facing some risk or a defect in your project, so it is an unplanned one, so you should be in a position to take care and handle the risk. So any doubt with respect to estimate and the expected impact of the defect?
No, ma'am.
So that is the last topic. So you can refer this YouTube video also for future, understanding more about the concepts. And the textbook reference is stated here. I will upload an assignment 2 based on the module. And so far in the module 2, we discussed the following topics. First, we started with the testing life cycle, roles and responsibilities, activities of test manager, test planning activity, forming and test team, the team members of the testing team, and the roles and the responsibilities of testing team, develop test plan reviews, and test case design strategies. Then we discussed black box testing approach. Under that, we discussed random testing, equivalence class partitioning, boundary value analysis. And then we discussed white box approach. There we discussed test adequacy criteria, coverage, control flow graphs, paths, loop testing, mutation testing. Then the last component is test execution. Here we discussed what is test data, life cycle of defect, defect tracking, defect decision stages, defect decision types, defect types, defect severity, defect analysis, and prevention techniques. So almost all are theoretical aspects. The thing is, you should know what is the definition, what is the method, what are the subheadings, what are the types, and sample code. If it is a method, what are we using any graphical representation, and take the sample code, convert to control flow graph or flow chart, or directed or undirected graph, and solve the what is the actual output. Take the values for the variables x, y, z, what is the actual output and what is the expected output. So these are the things you should know: what is what are the subheadings, what are the keywords, and any diagrams related to the topic. It's almost a theoretical one. You should understand and you can write it on your own words. I have given you more slides. Initially, I given the slides for module 2 is around 320 slides. Now I eliminated some additional examples. There are so many. I gave you more examples, and more references taken from different books. Now I reduced it to around I think 120 pages. I think now the module 2 comes around less only. In the around 230 pages are there, but it's around 200 pages. But you can read only the important points. The additional slides are for your understanding only. Okay. I already uploaded all the Zoom videos in the Google Chat. Just to go through the module 2, all are theoretical aspects, and examples are clearly stated in the PPT slides itself. I have taken the PPT slides from so many sources, so you can easily understand. You go through it. If you have any doubt, you can ask me in the next class. Okay, in Java, how many units covered?
3. We have covered 3 so far.
Sir is in 3rd unit.
Yeah. We're gonna start the 4th. We have started the 4th.
What about software engineering? How many modules covered?
2 modules.
2 covered, huh?
Yes.
Okay, I think anyhow your OET 1 will be based on 1st and 2nd module only. The dates are not yet fixed. I will tell you. Again, tomorrow we'll have one class. Okay. We just go through the topics of module 1 and 2. If you have any doubt, ask me in the next class. And Rahul, I will send you the Google Classroom code. Please join in the Google Classroom. Okay.
Okay, ma'am.
You joined in another Google Classroom, Java software, neuromorphic computing.
Okay.
You join in all the Google Classroom. Okay, you will get all the material.
Yes, ma'am. Okay, ma'am.
You go through the content. You go through the content of module 1 and 2. If you have any doubt, I will conduct you separate clarification class for you. Okay. I will revise you the topics once again.
Okay.
So if you want any syllabus material, you can message me. I will share with you. Okay.
Okay.
Or you can ask your classmates, Rahul, and you can ask your classmates, Naveen and Ahmed. They will also give you the syllabus PPTs already shared. Okay.
Yes, ma'am.
Okay. Okay. Shall I end the class?
Okay.
Thank you.
The material is already uploaded. Once again, I will upload the updated one. You just to go through the content. You need not memorize or you need not write the same. You need to understand what is what, and you can write the answers on your own. Okay.
Okay, ma'am.
Thank you.